Cutler hammer BR816L125DSP panel can be used as service equipment if certain conditions are met. These conditions are: firstly, a main breaker must be used. Secondly, no more than 6 service disconnecting mains are provided. Thirdly, the panel is not used as a lighting and appliance panel board. Let's define what each of these terms mean in more detail. A main breaker is a circuit breaker installed in the main electrical panel. Its purpose is to protect the entire electrical system. It is typically rated for a higher amperage than the other circuit breakers within the panel. The main breaker is designed to trip if the total electrical load on the system exceeds the panel's capacity. This prevents overloading and potential damage to the electrical system. Service disconnecting mains are circuit breakers or fuses installed in the main electrical panel. These are used to disconnect the electrical service from the building. They are typically rated for the same amperage as the main breaker. They are designed to trip if there is a fault in the electrical system. This allows for safe disconnection of power for maintenance or in emergency situations. A lighting and appliance panel board is a specific type of electrical panel. It distributes electricity to lighting fixtures and appliances. It typically contains a number of circuit breakers or fuses rated for lower amperages than those found in a service equipment panel. These lower amperage ratings are suitable for the individual circuits that power lights and appliances. In summary, if the Cutler hammer BR816L125DSP panel is used in accordance with these conditions, it is acceptable to use as service equipment. This means ensuring a main breaker is in place, limiting the service disconnecting mains to 6 or fewer, and avoiding its use as a lighting and appliance panel board. It is important to always consult the manufacturer's documentation and local electrical codes for specific requirements and safe installation practices. If any of these conditions are not met, the panel should not be used as service equipment. It is also vital to adhere to all relevant electrical codes and safety regulations when installing and working with electrical panels and service equipment. Remember, electrical work can be dangerous, and it is always recommended to consult a qualified electrician if you are not comfortable or familiar with the procedures. Safe electrical installations are crucial for protecting people and property. Proper grounding and bonding are also essential components of a safe electrical system. Grounding provides a path for fault current to flow back to the source, allowing the circuit breaker to trip and de-energize the circuit. Bonding connects all metal parts of the electrical system together, creating a low impedance path for fault current. This helps to prevent electrical shock hazards. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. It is important to select the correct size overcurrent protection device for the circuit being protected. Using an overcurrent protection device that is too large can allow excessive current to flow, which can damage equipment or cause a fire. Arc fault circuit interrupters of size are a type of circuit breaker that is designed to protect against arc faults. Arc faults are dangerous electrical faults that can cause fires. Size are required in many areas of the home, such as bedrooms and living rooms. Ground fault circuit interrupters, GFCIs, are a type of circuit breaker that is designed to protect against ground faults. Ground faults occur when electricity flows to ground through an unintended path, such as through a person's body. GFCIs are required in areas where there is a risk of water exposure, such as bathrooms and kitchens. Surge protector devices, SPDs, are designed to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, power outages, and other events. SPD can help to prevent damage to sensitive electronic equipment. When working with electrical systems, it is important to always follow safe work practices. These practices include: firstly, always de-energizing the circuit before working on it. Secondly, using insulated tools. Thirdly, wearing appropriate personal protective equipment, PPE, such as gloves and eye protection. Also, always test the circuit to ensure that it is de-energized before working on it. Electrical panels should be installed in a location that is easily accessible and free from obstructions. The panel should also be protected from moisture and physical damage. Electrical panels should be inspected regularly to ensure that they are in good condition. Look for signs of damage, such as corrosion, loose wires, or broken circuit breakers. If any damage is found, it should be repaired immediately. Proper labeling of electrical circuits is essential for safety and troubleshooting. Each circuit breaker should be labeled with the name of the circuit that it protects. This will make it easier to identify and to energize the correct circuit when needed. Electrical codes and standards are constantly evolving to improve safety and efficiency. It is important to stay up to date on the latest codes and standards to ensure that electrical systems are installed and maintained properly. If you are planning to install a new electrical panel or make any changes to an existing electrical system, it is important to obtain the necessary permit from your local building department. This will ensure that the work is done in accordance with all applicable codes and regulations. Electrical inspections are conducted by qualified electrical inspectors to ensure that electrical systems are safe and compliant with codes. If you are having electrical work done, it is important to have it inspected by a qualified inspector. Electrical safety is everyone's responsibility. By following safe work practices and maintaining electrical systems properly, you can help to prevent electrical accidents and injuries. Remember that electrical systems can be complex, and it is always best to consult a qualified electrician if you have any questions or concerns. Furthermore, consider the specific load calculations when determining the appropriate size of the main breaker and feeder conductors for the electrical panel. The National Electrical Code, NEC, provides guidelines for calculating the load based on the square footage of the building, the types of appliances and equipment that will be used, and other factors. The load calculation will help to ensure that the electrical system has enough capacity to handle the expected electrical demand. When selecting conductors for the electrical panel, it is important to consider the ampacity of the conductors. Ampacity is the maximum amount of current that a conductor can safely carry. The NEC provides tables that list the ampacity of different types of conductors based on their size, insulation type, and installation method. It is important to select conductors that have an ampacity that is equal to or greater than the of a current protection device protecting the circuit. The NEC also specifies requirements for the grounding and bonding of electrical panels. Grounding provides a path for fault current to flow back to the source, allowing the circuit breaker to trip and to energize the circuit. Bonding connects all metal parts of the electrical system together, creating a low impedance path for fault current. This helps to prevent electrical shock hazards. Electrical panels should be properly ventilated to prevent overheating. Overheating can damage the electrical components and create a fire hazard. The NEC specifies requirements for the ventilation of electrical panels. Surge protection is an important consideration for protecting sensitive electronic equipment from voltage surges. Voltage surges can be caused by lightning strikes, power outages, and other events. Surge protective devices, SPDs, can help to prevent damage to electronic equipment. When installing an electrical panel, it is important to follow the manufacturer's instructions carefully. The manufacturer's instructions will provide specific details about the installation process and any special considerations that need to be taken into account. Also, remember to properly torque all connections in the electrical panel. Loose connections can cause overheating and arcing, which can lead to fires. Use a torque wrench to ensure that all connections are tightened to the manufacturer's specifications. Before energizing an electrical panel, it is important to test all of the circuits to ensure that they are working properly. Use a multimeter to check the voltage and current on each circuit. Also, check for any shorts or ground faults. If any problems are found, they should be corrected before energizing the panel. Regular maintenance of electrical panels is essential for ensuring safety and reliability. Inspect the panel regularly for any signs of damage, such as corrosion, loose wires, or broken circuit breakers. Also, clean the panel to remove any dust or debris that may have accumulated. Proper documentation of electrical panels is important for troubleshooting and future maintenance. Keep a record of the panel's location, the circuit breaker schedule, and any modifications that have been made to the panel. This information will be helpful for anyone who needs to work on the electrical system in the future. Always consider the working clearances around electrical panels. The NEC specifies minimum working clearances to provide enough space for electricians to safely work on the panel. These clearances vary depending on the voltage of the system and the location of the panel. And be aware of the potential hazards associated with working on electrical panels. Electrical shock is a serious hazard that can be fatal. Always de-energize the circuit before working on it and use insulated tools and equipment. The information provided here is for general guidance only and should not be considered as a substitute for professional electrical advice. Always consult with a qualified electrician for any electrical work that you are not comfortable performing yourself. Additionally, consider the specific requirements of your local electrical codes and regulations. Local codes may have additional requirements that are not covered in the NEC. It is important to comply with all applicable codes and regulations to ensure the safety of the electrical system. For example, the NEC Table 310.15 B16, which was formerly Table 310.16, provides ampacity ratings for conductors based on insulation type and temperature rating. When selecting conductors, make sure to use the correct ampacity rating for the specific conditions of the installation. This will help to ensure that the conductors can safely carry the expected current. Furthermore, consider the dirting factors that may apply to conductors. Dirting factors are used to reduce the ampacity of conductors when they are installed in certain conditions, such as in conduits or in areas with high ambient temperatures. The NEC provides tables and formulas for calculating dirting factors. It is important to apply the correct dirting factors to ensure that the conductors are not overloaded. Also, consider the voltage drop in electrical circuits. Voltage drop is the reduction in voltage that occurs as electricity flows through a conductor. Excessive voltage drop can cause equipment to malfunction or not operate properly. The NEC provides guidelines for calculating voltage drop and recommends that voltage drop should not exceed 3% for branch circuits and 5% for feeders. And don't forget to properly label all electrical equipment, including the electrical panel, circuit breakers, and conductors. Proper labeling is essential for safety and troubleshooting. Use permanent labels that are easy to read and understand. This will help to prevent confusion and ensure that the correct circuits are de-energized when needed. Finally, remember that electrical safety is an ongoing process. Regularly inspect your electrical system for any signs of damage or wear and tear. Have a qualified electrician perform a thorough inspection of your electrical system every few years to ensure that it is safe and compliant with codes. This will help to identify any potential problems before they become serious hazards.